The most complicated kind of question is when you go from grams to atoms or atoms to grams, because there is no direct line between grams and atoms. So I want to make sure that none of you are putting grams and atoms together in the same conversion factor. We have two conversion factors. We have 6.022 times 10 to the power 23 atoms or molecules per 1 mole. And 2, we have grams per 1 mole. This is standard. It's a constant. It doesn't change. It's always 6.022 times 10 to the power 23 atoms or molecules per 1 mole. This is based on the periodic table. And this is atomic mass. So what happens if I ask how many grams are in 3 times 10 to the power 3 atoms of carbon? Okay, this is why I want you to set up the problem the way that I've told you to set it up, because you need to see where you're starting and you need to see the pathway that you need to get to. So the first thing that you do, again, is you write down the data that I give you, 3 times 10 to the power 3 atoms of carbon, leave room for your conversion factors, and the unit I'm asked to find is grams of carbon. Now, you look at your two conversion factors. You have atoms, you need grams. There is no one conversion factor that will get you straight from atoms to grams. So then you look at your conversion factors and you say, okay, well, I have atoms, I don't want atoms. So what can I change atoms into that gets me closer to grams? And you should look at A and say, hey, A has atoms. So that means I can put A in as my first conversion factor. So let's do that. If I want to get rid of atoms and I need grams, getting rid of atoms puts me one step closer to getting to grams. So I want atoms on the bottom to cancel. So I put 6.022 times 10 power 23 atoms and 1 mole on top. Now I can cut atoms. Now look at what I have left. I have moles, I need grams. I can put another line there showing that I'm going to put in a second conversion factor because I can use grams per mole to go from moles to gram. This is what I mean about a step-by-step. You go from A to B, B to C, C to the answer, okay? So I want 1 mole on the bottom so I can cut. I need grams of carbon at the top, but I need to go to my periodic table. I go to carbon and the average atomic mass, 12.011. So I go back and I put in 12.011. I cut my moles, and here's where it's very important to keep your numbers straight. So I want a calculator. Now, if you have a Casio, and like I said, mine's at school, so I left it there, but it's like Casio calculators. I do believe it's at the bottom of the calculator next to the equal sign. There's a button there that says times 10 to the X. That is your best friend, your chemistry best friend. But let me do this first. So I'm gonna put this in brackets. I've got 3 times 10 power 3. Okay, so that's 3,000, makes sense. Times 12.011, because those are the numbers at the top. Okay, and that's equals. And then I'm going to divide by, and again, I'm going to use brackets because I'm using a non-scientific, I'm using my iPad. So then I'm going to do 6.022 times 10 power 23 end bracket. So that's Avogadro's number, equals. And I get 5.98 times 10 to the minus 20. Now, does that answer make sense? It sure does, because I've got 3,000 times 12. So let's just round that to 30,000, or that's 3 times 10 to the 4th. and I've got 10 to the 23 down there. So negative 20 makes sense. Okay. Right. So on your calculator, you got your screen up there, and then I think these are your equal sign, and you have a button here, and this button says times, blarg. Oh, Bridgel. Okay, calculator, here's your button. I'm gonna blow it up. This says times 10 to the x, okay? This is your best friend. So if you're going to use this number, like literally what you would type in your calculator, 5.98, and then you would type in that button times 10 to the x, and then you do the little minus sign 20. Now, I know some of you guys like to use different versions or like different combinations of buttons on the calculator, but I'm telling you, when it comes to exponents and scientific notation, that button is your best friend. So it's 5.98, magic button, negative 20. That gets you the same, if you were typing that number in, that's what I mean. All right, so let's do one more of the double conversion factor problem. How many atoms are in 53 grams of copper? Okay. 53 grams of copper. And then I'm going to put an equals there, and then I've got atoms. So I know where I'm starting and I know where I'm going. The first thing that I'm going to do, again, I'm going to look up here. I start with grams, and I don't want grams, so I'm going to use this to get rid of grams. Grams are on the bottom, 1 mole on top. Go to the periodic table, find copper. It's here. No, that's helium. 63.546. Oops. 63.546. Okay, cut my grams. And then I want atoms, and I have moles, so that's Avogadro's number. And I want atoms on top to match where it is over here. I want 1 mole on the bottom, Avogadro's number. Cut moles, get out my calculator. And I got 53 divided by 63.546 times, I'm gonna do bracket, 6.022 times 10 power 23 equals 5.022 times 10 power 23 atoms. And does that make sense? Yes, because I've got 53 divided by 63. Let's just call that like a little bit less than 1. So a little bit less than 1 times 6 times 10 power 23 should be less than 6 times 10 power 23. And that's what I have.